We are told the product of two even numbers is even, and that is true for any two even numbers. The product of an odd number and an even number is even. That is also true for any two numbers, two integers. The product of p and r is odd. And they say if p and r are integers, then according to the statement above, which of the following is a valid conclusion? And you only need to pick one of these. So pause this video and see if you can answer that. Okay, now let's do it together. And we're just going to go through each of these choices and see if these can be a valid conclusion. So the first statement says only p is odd. So only p is odd means that r would be even. So let's just use two examples. Let's say that p is 5. So I'm just picking an arbitrary odd number. And let's make r 4. So what's the product of 5 and 4? 5 times 4 is going to be equal to 20, which is even. So if only p is odd, the product is going to be an even number. But they say that the product of p and r is odd. So this cannot be true because here the product is even. So we can rule that out. And another way to think about it, only p is odd means that you have the product of an even and an odd, because then r would have to be even. Well, that's the second case over here, and they tell us that your product is going to be even. We're in a situation where the product is odd, so once again we would rule that out. Choice B, only r is odd. So it's the same idea. If r is odd, then p is even. But we could, if we wanted to try out values, we could say, let's make r equal to 5 or 3 or 7 or 9, some odd number. And let's make p even, which would be 4. And once again, you'd get 5 times 4 is equal to 20. The product would be even, not odd. So this is not a valid conclusion. Once again, if you have an odd and an even, that's this second scenario up here where we know the product will be even, not odd. Either p or odd is both, but either p or r is odd, but not both. Well, that's these other two cases. If p is odd, but they're not both odd, then we're in choice A scenario. And if r is odd, but p isn't, well, we're in choice B scenario. And so I would rule that one out as well. This is going to be an even times an odd, which is the second scenario where the product is even. They tell us that, and you could try out some values to verify that. But we want to figure out statements about p and r so that we know that their product is odd. Both p and r are odd. So you could try out some values if you like to give you confidence here. So let's say 3 times 5. That's 15. That checks out. So if this is odd, that is odd. Their product's odd. You could do 7 times 9 is equal to 63. That checks out. You can keep trying this out, but this one's holding up pretty well. In other videos, we could try to prove it, but this one's looking pretty good. I'll put a smiley face there. Both p and r are even. Well, they tell us if the product of two even numbers is even. So this is going to be an even product right over here. But they told us that the product of p and r is odd. So we could rule that out. You could also try some examples here. You could say, well, let's say 2 times 4. Well, 2 times 4 is 8. Even times even is an even. But p times r has to be odd, so we can rule that one out as well. So we can feel very good about choice D.